Rockets are by far the most common type of machine used to get stuff into orbit, but how do they work? It is a common misconception that rockets push against something, like the ground and/or air. Were this the case, rockets would not work in a vacuum, where there is by definition nothing to push against. This misconception was at the heart of a New York Times editorial on January 13, 1920, which ridiculed the then nascent field of rocketry as absurd. Fortunately, the Times promptly retracted their editorial on July 17, 1969, when Apollo 11 was 3 days from the moon. To the great relief of the Apollo astronauts, as well as the multi-billion-dollar satellite industry, rockets work in a vacuum because they are fancy Newton's third law machines. Newton's third law of thermodynamics states that to every action there is always opposed an equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. What does this mean? Generally speaking, it means that it is impossible to push or pull on something without that something also pushing or pulling back on you. To illustrate, imagine a bumper car with its nose to a wall. The harder you push on the accelerator, the harder the car pushes on the wall. However, no matter how hard you accelerate, the bumper car never moves. In order for this to be true, the wall must be pushing back on the car exactly as hard as the car is pushing on the wall at any given moment. You can see this even more clearly if you drive the bumper car into the wall. The faster your car is moving when it hits the wall, the harder it pushes the wall when they hit. Because of Newton's third law, the harder the push from the car on the wall, the harder the wall will push back, and the farther and faster the bumper car will bounce off the wall. This is Newton's third law in action. Okay, bumper cars are fun, but what does this have to do with rockets? Well, let's consider another example. This time, imagine that you are in a canoe filled with bowling balls in the middle of a lake. There is no wind, no current, and you have no paddle. However, if you throw a bowling ball with enough force that it flies off the back of the canoe, it will also act upon you with equal and opposite force. Assuming you don't fall down, this energy will be transferred from you to the canoe, pushing it forward along the surface of the lake. Just as the wall in the previous example always pushed back on the car with an equal and opposite push, so also the bowling ball will always oppose your push with an equal and opposite push. This means that the greater the force with which you throw the bowling balls, the greater the force with which they push you, and the faster your canoe moves. If you have enough bowling balls, you will be able to accelerate yourself fast enough to reach the shore solely by throwing them off the back of the boat. A rocket is kind of like a canoe full of bowling balls, except instead of a lake shore, it is trying to reach orbit. And instead of bowling balls, it is throwing out hundreds of tons of exploding gas. For every molecule of exhaust a rocket pushes backward, that molecule of gas pushes the rocket forward a tiny amount. This is why rockets work on the ground, in the atmosphere, or in the vacuum of space.